Hello guys, so we are back again, and in this session we will do some more couple problems on GP. Okay, so the first problem which we are going to tackle is this question. Okay, it says AGP, arithmetic geometric progression, consists of an even number of terms. If the sum of all the terms is 5 times the sum of the terms occupying odd places, then find the common ratio. Okay, so we want to find R. So let me take a GP. AR, AR square, AR cube, like that. Okay, you know it is AR n minus 1. Okay, now what is doing? It is sum of all the terms. Okay, if you can sum of all the terms, if the sum is 5 times, okay, is 5 times the sum of the terms occupying odd places. Okay, even number, here it is 2n. Okay, even number of terms. Now its sum is what? A into R minus 1. Here there will be 2n, right? And R minus 1, right? It should be equal to what? 5 times. Now if I take a sequence, means at odd places, right? AR square, AR raised to 5, AR raised to 4, and so on. Okay, so the first term is A, common ratio is R square. So here also R2n, it will be R2n minus 1 upon R square minus 1. The common ratio is R square. Now, since we have not studied AGP, so I will not consider that you know all the things, okay, like common ratio and like all that stuff. Okay, less than minus, we will just taking it is greater than. Okay, we don't know anything about AGP like that. Okay, since we have not done a single thing. Okay, so I will assume that we don't know about the R property. Okay, it is less than 1. Okay, like that. So I'm doing it like this only. So here you can directly see this will cancel out here. Okay, in the starting A term, means here there will be A will cancel out, which will give me in the end what we are left with, 1 upon, this should be 1, this is 5 by R plus 1. Okay, which gives me what? Which gives me R plus 1 is equals to 5, which gives me R is equals to 4. Okay, so we are done with this problem. It was nothing but just taking a GP, taking its even position, getting its sum, taking the GP, all number of GP sum. Okay, it can be odd, even. Okay, doesn't matter. Okay, all you should be focused is consistent with the formula. Okay, so let's move on to the next question. The next question is this question. Okay, it says if the sum of n terms of a GP is 3 minus 3n plus 1 upon 4 by 2n. Okay, then find the common ratio. Okay, again we want to find the common ratio, but in this problem what we can do, okay, they have given us a general Sn. Okay, 3 minus 3 by n plus 1 upon 4 by 2n. Okay, so we can do many things with it. Okay, but one thing, we want to find common ratio. So T1 is equals to S1 is equals to what? 3 minus 3 power 1 plus 1, okay, upon 4 power 2 into 1. Okay, like that. So what we are getting? 3 minus this is what? 3 square, which is 9 by, and this is 4 square, which is 16. Okay, so we got our T1. Similarly we can get our T2. Okay, how we will get our T2? Okay, we can get S2 is equals to T1 plus T2, right? Sum of two terms, and S2 is nothing but 3 minus 3. 2, if I put, this will be 3 cube, and if I put 2 here, it will be nothing but 4 power 4. Okay, right? 4 power 4. Okay, this will be nothing but 4 power 4. Okay, so what we can do? T1 we have 3 minus 9 by 6, 16, and this is T2 which we need. Okay, why we need T2? Because R is nothing but T2 by T1. Okay, so if we know T2, we know T1. How we find T1? t1 like this, t2 we are finding like this. Okay, sum of two terms. Okay, so it will be what, 3 minus 27 by 256, 256, yeah, 256 minus 3 plus 9 by 16. Okay, should be equal to t2. Okay, should be equal to t2. Now what we can do, we have to calculate this. Okay, so if I calculate this, what I get, let me calculate. Okay, we are getting t2 as 117 by 256. Okay, we are getting t2 as 117 upon 256. Further on, what r was t2 upon t1. Okay, so we will just put the value 117 upon 256. Okay, upon t1. T1 was nothing but, okay, we want to calculate t1 also. T1, if we calculate, it is nothing but 39 by 16. Okay, so what we have, 39 by 16, 16 okay, this is nothing but, okay, 3. So what we have, final answer 3 by 16. Okay, so we got the common ratio. The basic idea was getting t2 by t1. Okay, and how we did it, that is important. Okay, now what we can, okay, yes, fine, we are done with this problem. Now let's move on to the next question. Okay, let me take the next question. The next question is this. Okay, this is the next question, which says prove that 6 till, okay, till n digit. Okay, n digit terms are here, the whole square plus 8 n digits are here also, and here 4 here 2 n digits are there. We want to prove this, that it is equal to this. Okay, but now let's find for each term. Okay, each term sum. Okay, and then prove it. Okay, product. Okay, product, and it, you can see it is in what, GP. Okay, r power 1 r square. Okay, and 6 cube, like that. Okay, now you must have understand what I mean. Okay, so it is in GP, that I am very sure. Okay, so let's find the product, means product of all these terms. Okay, how we can do that? Okay, if we consider it in series, sequence, doesn't matter. So I can write this term like this. How? This is in 6. I can write 6 into 2. I am moving from here. Okay, we have already done a problem on this. We move from here to here. Listen, just in this direction. Okay, so first term 10 to the power 0, 6 into 10 power 1 plus 6 into 10 power 2 plus 6 into 10 power 3. Okay, and still so on. What? 6 into 10 power n. Okay, now we want to get the value. Okay, how we can get the value, that is the crucial thing. Okay, so this is nothing but 6 into 10 to the power 1, 6 into 10 to the power 2, and so on till 6 into 10 to the power n. Now if this is very simple, that this 6 will move out and we will be left with t square and t cube till what, tn, because n terms are there. Further on, here we have taken separate n terms. Okay, they have told. Okay, otherwise we have taken 2 n terms like that. Okay, so what we can do now, we want to find the sum of this term. The first term is 1 into 10 power n minus 1, 10 minus 1 9. Okay, this was simple. Further on, if we calculate, we came to know 2 by 3 into 10 to the power n minus 1. Okay, basic calculation thing. Okay, so we got one thing. Let's place it as a. Now let's see the second thing. Similar thing will happen, so I'm not going to explain that thing. Okay, we will do with 8. It is nothing but, this will be like this, 8 plus 8 into 10 power 1, 8 into 10 power 2, and so on till what, 8 into 10 to the power n. We have already discussed this feature in the previous question in very detail. Okay, that was more tough than this. Okay, so if I take 8 common, what I'm left with, 1 plus 10 square. Okay, and till so on till what, 10 power n. Okay, so now we want to find the sum of this. How can we can find? This is 1 into 10 to the power n minus 1 upon 9. Okay, so it is nothing but 8 by 9 into 10 to the power n minus 1. Okay, so we are done with this. let me take it as b. Okay, now let's find the fourth one. It will be nothing but 4 into, okay, 10 power 0 plus 4 into 10 to the power 1 plus 4 into 10 to the power 2. Okay, till what? Here the crucial part is it will be how many digits? 2 power 10, 2 into n. Okay, 2n digits are there. Okay, here it was moving to n digits, here it will move to 2n digits. Okay, that is the trick part. Okay, if you don't do that, your answer will come wrong. Okay, that is also given in the problem. If I take here 1 plus 10 square plus 10 cube till what? Till 10 power 2n. Further on, if I take the sum, this is 1 into 10 minus 10 power 2n minus 1 upon what? 9. Okay, so the final answer is 4 by 9 into 10 the power 2n minus 1. Okay, so now let me take the next page and move on. Okay, and let's do it further. Okay, so now let's prove this, what it was. Okay, what we had in a 2 by 3 into 10 the power n minus 1, we need its whole square. One more thing, then we want to add 8 by 9 into 10 the power n minus 1. Okay, this thing we want to prove it equal to this thing. Okay, that is the main task. Okay, so it is very simple. 4 by 9, this is very easy. 10 the power 2n minus 2 into 10 the power n plus 1. Okay, just a plus b the whole square formula. 8 by 9, this will be as it was before. Now we will make the base common. It will be 9 and 4 10 power 2n minus 8 10 the power n plus 4. Here it will be 8 10 the power n minus 8. You can clearly see these two will cancel out, which will give me 4 into 10 the power 2n okay, plus 4 upon 9, which gives me further 4 by 9 is nothing but 10 the power 2n. Okay, 2n. Okay, it will be minus 4. Okay, minus 4, and it will be minus 1. Okay, so hence we have proved this. Okay, you can see we have proved this, just the basic calculation thing. Okay, don't do silly mistakes. Okay, so we are done with this problem. This was question number 3. Okay, all the concept we have already discussed. The basic thing was don't do mistake in considering the term. We move from here to here, from here to here, from here to here. The number of terms is in the 10 power that number of terms upon 10 minus 1. Okay, that was the crucial thing. Okay, now let's move on to the next question. Okay, this was question number 3. Okay, we are moving towards question number 4. It says find the sum of x plus y plus x square plus xy plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube till n terms. Okay, now okay, one thing which you can realize in this question, first do you know this x minus y power n expansion? It is nothing but x minus y into x power n minus 1 plus xy plus y minus n minus 1. Okay, and it goes on till, okay, like that, n minus 2. Okay, like that. So what you need to know, how we can create this thing here. Okay, now if you don't understand this, let me make you understand. X square minus y square is what? X minus y into x plus y, right? X cube minus y cube is what? X minus y into x square plus xy plus y square. Similarly, okay, till here, so you can get an idea that x4 minus y raised to 4 will be what? X minus y into x cube plus x square y plus xy square, okay, plus y cube. Okay, if you have the knowledge, if you have the knowledge of this thing, your job will be done. Now here all the terms are present, like here. Okay, the main thing is we want x minus y, so why don't we do one thing? We multiply and divide both the side, means multiply and divide by x minus y. So what we have, 1 upon x minus y we have here, and here it will be x minus y into x plus y. Okay, here it will again have x minus y into x square plus xy plus y square, right? And here it will again have x minus y into x cube plus x square y plus y x square xy square. plus y cube. Don't you agree? Okay, don't you agree? If we move on further, what we see, 1 upon x minus y. Okay, this thing. Okay, here. Okay, now this is nothing but x square minus y square, as we have discussed. Okay, this is x cube minus y cube. This will be what, x4 minus y4, until so on, x power n plus y power n. Okay, now if we now here comes the second type of this question. Okay, although we have done so many decent number of questions, so that you can understand, we will take these terms, okay, and make a GP, and take these terms and make a GP. So x square plus x cube plus x raised to 4 till how many, x power n. Similarly, we will take minus outside, we have y square, y cube, y raised to 4, okay, till what, y power n. Okay, we will take these terms and make a GP. So what we have, x minus y here, and here I have my first term as x, and here is x power n minus 1 upon x minus 1. Similarly, here what we will have, y into y power n minus 1 upon y minus 1. Okay, so this was our answer. Okay, all the thing were very simple, but you need to know this thing. Okay, if you know this thing, your job is done. Okay, the thing which you can learn is this format. Okay, it appears many times. Okay, be careful. Okay, so let's move on to the next question. The next question is this question number 5. Okay, which tells as follow, and here find the sum of n terms of the series 4 by 3 plus 10 by 9 plus 28 by 7 plus, okay, and so on. Now one thing which you can directly understand, okay, even a class 10 child will understand that I can write this thing as, okay, like this, plus 1 like this. Okay, these things are now you must become familiar with. Okay, 4 by 3, whenever you see higher power upon lower power, it can be done like this. Okay, so in GP, okay, so here if I add this 3 into 1, 4 by 3, okay, like that. Okay, you can clearly see we are forming the same thing. Okay, now should I do one thing, I should arrange this 1 by 9. Don't you see it is a GP? Here it is 3 cube, okay, and so on. Okay, 3 items, 3 power n. Okay, and here it is 1 plus 1 plus 1 plus till n times n term. So what we can do, the first term is 3, okay, and 1 minus 1 by 3 power n. Okay, so here it will be 1 minus 1 by 3. Okay, so further on here it will become n. 1 added n times is nothing but n. Okay, if we do further, 3 will cancel out, it will give me 3 power n minus 1 upon 3 power n, okay, into 2, okay, plus n. Further on, if we do, what we have, 3 power n minus 1 plus 2 into 3 power n into n, okay, upon 2 into 3 power n. Okay, if I take 3 power n common, what I have, 3 power n common, what I have, 2n plus 1, okay, 2n plus 1, 2n plus 1 and minus 1 upon 2 into 3 power n. Okay, so we are left with this thing. Okay, did we did any mistake or what? Did we did any mistake? No, I don't think we have did. Okay, so we are done with this problem. The basic thing was understanding this format, 1 by 3 plus 1, 1 by 9, the denominator 1 by 9 plus 1. Okay, that format you should understand. In the previous volume, the format was what, x into x plus y into x minus y, that format of series, and this format. Okay, these are algebra series. Just keep in mind these different series, okay, so that when they appear in front of you, don't be surprised like that. Okay, and you should be able to solve them. Okay, they can do just a little manipulation about it, and they cannot do much thing with that. So you can do these questions very easily if you have done it at least once. Okay, so the sixth question is as follow. Okay, this is the sixth question. Okay, let me read the question and then we will do. It says if p of x is equals to 1 plus x square plus x raised to 4 plus and so on till x power 2n minus 2, okay, upon 1 plus x square plus till plus x power n minus 1 is a polynomial in x, okay, then find the possible value of n. Okay, they want us to find the possible value of n. Now if it is a polynomial and it is divided by this number, okay, it will have some root, okay, and they are telling we want to find the value of n for which this divisible is possible. Okay, this divisible is possible, that x has some root, p of x has some root. Okay, that is the main motto. Okay, now logically you can directly straightforward think that how we can divide this, but now one more thing, this question is from sequence and series, so you can definitely think, and if I find the sum of this and sum of this, then I can know when its root is possible at what position. Okay, okay, so we are going to trying to do the same thing. Okay, let's just find the sum of this. Okay, now one more thing, this is just a way of representation of n term. It doesn't mean that there are 2n minus 1 term, minus 2 term. Okay, children mostly do that mistake. It is just a representation. If I here put 1, okay, it is 2 minus 2 0 1, okay, like that, but here are n terms. Okay, don't get confused. Okay, here n minus 1, okay, this is quite logically, here you can use this also to get understand the terms n minus 1 because 1 is covered here, so it is total n terms. Okay, okay, so please don't be confused in that. Okay, now we want to find the sum formula. For the first, we know a is what, 1, r is what, x square. So let's find the sum of this thing. It is nothing but 1 into x square. Okay, x square n. Okay, x square is r. Okay, into n minus 1 upon what, x square minus 1, right? Right, now let's find the sum of this. Second, here a is what, again 1, but here r is x, that is the, so be careful. Okay, 1 upon x power n terms are here also, minus 1 upon x minus 1, right? Now let's divide them. If I divide them, okay, if I divide them, we have p of x is equals to x power 2n minus 1 upon x square minus 1, okay, upon x power n minus 1 upon x minus 1. This moved up. Okay, now this thing you can easily see that this x square, a square minus b square formula will work. Okay, we can also apply a square minus b square formula on this x square n minus 1. Okay, we can apply this formula on this thing also. How it will be x power n minus 1, x power n plus 1. Okay, and this one x minus 1 will cancel out with this, giving me x plus 1 in the end, and here x power n minus 1 is there also, so this and this will nullify, giving me x power n plus 1 upon x plus 1. So we got this thing. Now they are telling divisible, and it is only possible if it has some root. Okay, it is divisible at what, if x is equals to minus 1, if x is equals to minus 1, p of x be equal to 0. 0 means it is a root. Okay, remainder is 0. Now one more thing, if I place p of x, 1 is not possible. Okay, 1 plus 1 2, not possible. Okay, now x is equals to minus 1 is possible only when if n is odd. Okay, if n is odd, or then minus 1 power n is nothing but minus 1. Okay, now if n is even, then it will be 1. Okay, if n is even. Okay, we want a root. Okay, it is divisible means it should have some root. Okay, divisible by this, so it should have some root. Okay, it is possible only if x is equals to minus 1, for which n should be odd. So all odd values of n are possible. Okay, are possible. Okay, all odd, 1 3 5, okay, doesn't matter. Okay, but n should be odd. Okay, that is the main key. Okay, now let's move on to the next question. Okay, this is question number 7. Okay, this question is of JEE advanced level. Okay, so be careful. Okay, and you should try to do it by yourself. If you even reach the half, then it's great for you. Okay, Now the question is like this: if an is equals to 3 by 4 minus 3 by 4 the whole square plus 3 by 4 the whole cube plus still minus 1 power n minus 1 into 3 by 4 the power n, okay, and bn is equals to 1 minus n, then find the least natural number n naught such that bn is greater than an for all n less than equal to n naught. Okay, now the question is telling that an is some this thing, okay, 3 by 4 minus like that, okay, and bn is 1 minus an. Okay, now they are telling find the least natural number n naught. Okay, there is some least natural number n naught such that bn which is 1 minus an is always greater than this an. Okay, now so we want to find the least natural number for this condition is possible bn. Okay, now can I do one thing? I can place bn value here. Okay, what we have bn value 1 minus an should be greater than an. Okay, so what I'm getting 2an should be less than 1, then we are getting an should be less than 1 by 2, right? This thing is very simple. Okay, you can easily understand why we did that. Bn, we put the bn value and just got a equation that an should be less than 1 by 2, then this condition will be possible, which is this condition. Okay, we got a generalized condition. Now we have an. Okay, an is a sum. Okay, you can clearly see it is a sum. Is it a GP? Yes, sure, it is a GP. A is 1, A is 3 by 4, sorry. R is nothing but minus 3 by 4. Here also it will be minus 3 by 4. Okay, now second most thing which is important, we got A, we got R. Now let's find the sum. Okay, an, which is just an, is nothing but 3 by 4, okay, into what, 1 minus, okay, 3 by 4 power n, right, 3 by 4 power n. Okay, further on here what we have 1, okay, here will be minus, okay, minus, R is minus into minus 3 by 4, okay, right, then 3 by 4 into what we are getting, okay, we have to, okay, we don't know about n, okay, that we want to find, so we cannot open this. Okay, 1 plus 3 by 4, okay, right, this is very understandable. This 4 will cancel out, which will give me 3 by 7 into 1 minus 3 by 4 power n. Don't you agree? We got this thing. Now we got this, and here an should be less than 1 by 2, and this is an, so let's substitute this value here. So what we have 3 by, okay, what we have 3 by 7, okay, 3 by 7, okay, should be 1 minus, okay, 3 by 1 minus 3 by 4 power n. Okay, this is an, okay, should be less than 1 by 2. Then in the next step, can I move this? All these terms are positive. 1 minus 3 by 4 power n, okay, should be less than what, 7 by 6. Very simple. Further on, minus 3 by 4 should by n should be what, 7 by 6 minus 1, okay, minus into minus 3 by 4 power n should be what, 1 by 6. Okay, now now the next step, how we can move this? Okay, how we can move this? Least natural number. Okay, we want to find least natural number. It is saying that the n value is least natural number. Natural number begins from what, 1. Okay, so it is always positive, so 4 by n is positive. Okay, so we can move it here. Okay, so here minus into minus 3 by n, okay, upon 4 by n upon 1 by, I can write it 2 by 3, okay, 2 into 3. Okay, so further on in the next step, what I will just put this thing, minus into 3 by n should be 4 by n, right, upon 2, okay, into 3. Now let me take the next page. In the next page, what we can do, we have minus 3 into 3n, or here if I move, we have minus 3 again, okay, and this is 4 by n, which I can write 2 by 2n, right, and here we have 2. Okay, then what we get, minus 3 power n plus 1 will become, this will become n plus 1, and this will become 2 by 2n minus 1. Okay, so now we want to find the and analyze this condition, okay, which we got. We are getting this condition. Now we are going to analyze this condition, what it naturally means. Now if n is even, okay, even like 2, 4, 6, okay, 8, like that. Okay, now it is even, then 2 plus 1 will become odd, so minus 3, okay, upon 2, 2 2s are 4, okay, 2 2s are 4, minus 1 3. Okay, now you can easily understand what I mean. What I meant is that this will always be negative and this will always be positive, so positive is always greater than negative. So 2, 4, 6 are all valid natural number. Now we want to find the least. Okay, now we want to find the odd. For at what odd natural number is it possible? Okay, so for odd, n is odd. Okay, odd. So odd will decide from where it will begin. Like if I have two even, okay, every even number satisfies this condition. That is simple. But it is not necessary that all odd number will satisfy this condition. Okay, you will understand why. If I get say third odd number 3, which is odd number, doesn't satisfy the condition, then second odd number is also not possible. Why? Because n is less than n naught. Okay, n is less than n naught. Okay, the number which is odd, okay, which is odd, which is always greater than n, which is even. Okay, you can understand this. Okay, this condition was given for that only. Okay, such that the natural number, the least, we want the least natural number n or not. Okay, if I say the even number are n, okay, even number are n, okay, even number are n, then they are always less than the odd natural number. Okay, but you know all odd natural number does not satisfy this condition. So if I place 3 and 3 does not satisfy, then the number, even number before that, will also be rejected. Okay, that is the main trick of this question. That's why I was telling this, that this question is of JEE advanced level. Okay, now if I take for n is equals to 3, then what does it means? 2 is n. Okay, n is equals to 2, then n is always less than or equal to n naught. Okay, so 2 is always less than 3. Okay, so we are going to analyze it for 3. Minus 3 by what we have here, minus here we have what, 2. Okay, no, we have 3 will become 4, and it is 2 by 3 to 6. Okay, 6 minus 1 5. Okay, is it possible 3 by 4, 2 into 5? Okay, let me check. Okay, 2. Okay, no, it is not possible. Okay, okay, it is not possible. Okay, so what we should do? Okay, what we should do? 2 to power 5 is big number. Okay, what we can do? Now let's analyze the second number, which is for n is equals to what? N is equals to 3. Okay, 3 we have analyzed. Let's analyze for 5. Okay, let's analyze for 5. It is not happening. Okay, you can check the value. I have calculated 3 power 4, 27 into 2, okay, into 3. Okay, 2 power 5 is means it is very big number. Okay, so okay, so we analyze that this condition is not, n is equals to 3 doesn't satisfy this condition. Minus 3 by 4 is greater than this. Okay, so this condition fails. Okay, now for n is equals to 5, which is less than, just greater than 4. Okay, so if 5 is rejected, 4 is also rejected. Like here 3 is rejected, so 2 is also not valid. Okay, now for n is equals to 5. Okay, so for n is equals to 5, okay, n should be less than, so here 4 is less than 5. Okay, now minus 3 power 4, minus 3 power what it will be, what I'm putting, 5 plus 1, here it will be 6. Okay, here will be 2 5 10 minus 1. Okay, 9. Okay, so 3 power 6 is again greater than this, so this also fails. Okay, now for n is equals to 6. Okay, for n is equals to 6, no, for n is equals to 7. Okay, for n is equals to 7, minus 3 by what it will be, 3 is 8. Okay, it will be what now, again 7 is greater than what, 6. So if 7 is rejected, 3 is also rejected. Okay, minus 3 power 8 into what, this will be what, 7. 2 7s are 14, 14 minus 1, so 2 power 13. Now here you can see I have calculated that this writes. Okay, this is right, this condition is right. So this n is equals to 7 satisfy this condition. What does it mean? That n is equals to 6 is the least possible natural number possible. Okay, after n is equals to 6 7 8 9 10, all natural numbers satisfy this condition. That was the main part. Okay, so n is equals to 6 is the least natural number. Okay, natural number which satisfies this condition, satisfies this condition. Okay, satisfies this condition. Okay, this question is of JEE advanced level, that's why you may not be able to understand it. Okay, but if you practice 2 to 3 times, let me teach you again. Okay, the whole thing. Okay, they have given some an series, okay, and some bn with a relation between an and bn is equals to 1 minus an. Then find the least natural number n naught such that bn is greater than an and n is always less than equal to n naught. Okay, they have given this. First I analyze the condition, I put bn value in this, which was always possible, and we got an is less than 1 by 2, which is more generalized of this equation. Okay, inequality. Okay, then we analyze this because we wanted to find an. After getting an, we will substitute it here. That was a general process. So we find out its sum. Okay, it is a GP, very understand. A is 3 by 4, R is minus 3 by 4. After calculating, we got 3 by 7 into 1 minus 3 by 4, where n we don't know. Okay, now after analyzing, we got what we got. After analyzing, we got minus 3 by n plus 1 is less than 2 by, okay, 2 by n minus 1. Okay, we got this condition. Okay, now we want to analyze this condition to get the n value. If n is even, like 2, 4, 6, the least even natural number are 2, 4, 6, 8. Okay, now for even natural number, we see n plus 1 will become an odd. Okay, so minus is always greater than plus. Okay, so this even numbers always satisfy this condition. Okay, now we want to find the odd. Okay, if any odd number from where it start, okay, it find the like 1, 5, 3. Okay, if 5 odd number satisfy the condition, then the number just before even will be even number. Okay, which will be 6. Okay, then it will also satisfy the condition. You are understanding what I am telling? So from that, all natural number will satisfy this condition. That is the main crucial you have to, like n is equals to 7 satisfy this condition. Okay, then number before will be 6. Okay, then it will also, from that, all natural numbers, so the least possible natural number is 6. Okay, now here similarly it was possible for all even natural number 2, 4, 6, because negative is always greater than positive. How? 3 is odd, negative, it will be negative, it will be positive. So no matter what the power is, even number will always satisfy this condition. Now for odd, we want to check. First odd number is 3. There is no way of checking that. Okay, it will be just stupidity of checking that number. Then we went on to 3. We checked it. Yes, it does not satisfy the condition. Minus 3 by 4. It becomes 4, which is even number, which makes minus positive. Okay, so here problem appears in odd natural number. Okay, so it will cancel out. Similarly, when we checked 5, here they are n and these are n naught. Okay, it is always true. Okay, they are always true. Even natural number are n naught. Okay, these are n, and n is always, n naught is always less than n. Okay, that was the condition. Now let me check. I'm sorry, n is always less than equal to n naught. These are n naught. Okay, so we did that. And similarly, 5 number which is odd, it also failed. So 4 is also rejected. Okay, if 5 is not valid, how we can take 4? Okay, we want to find the least natural number. After that, all natural numbers satisfy this condition. Okay, then we take 7 satisfied this condition. So 6 also satisfied just before the number. So 6 is the least possible number. After the 6, 7, 8, 9, 10, all the natural numbers will satisfy this condition. That was the crux of this question. And so hope you have understand this question. I am emphasizing on this question continuously because this question is of real importance. Okay, you need to understand this question to do some decent good level problems. Okay, please understand, I am making you think again. Okay, I am teaching all the things again. What I am telling, that an is, they have given us a series. Okay, and bn is given 1 minus an. Okay, they find the least natural number n naught. Okay, least natural number n naught such that bn is always greater than an for all n should be less than equal to n naught. Okay, okay, now one more thing. Okay, least natural number. Now we got one condition, which was what? Bn is equals to 1 minus n, and we got one condition. So we substituted bn value and we got a more simplified condition. An is less than equal to 1 by 2. After getting, we got a general idea, we want to find an. We just did the summation of this. We got some value of this. Okay, we substituted here, and then we got this thing which give me a generalized equation. We need to analyze this equation. After understanding this question very generally, we got n is equals to even all natural number which are even satisfy this condition. But for odd, it is not true. Why it is not true? If I place 3 here, it will become 4. So minus 3 can also become positive. So inequality for negative and positive, you need to analyze that. Okay, you have learned in inequality chapter that it is crucial. Okay, you need to analyze it. So for n is equals to odd, we are going to analyze it. For n is equals to 1, this condition fails. Okay, so 2 is 2. After 2 it is 3. Okay, 3 also fails. Okay, n is equals to 3 also fails. Similarly, n is equals to 5 also fails. Okay, so all the natural number which are even before 5 will also be rejected. Okay, we want to find the least natural number. After that, all natural numbers satisfy this condition. And at n is equals to 7, and before it is 6, so 6 will also be included because n is equals to 7, which is odd, satisfy this condition. So after that, all terms will satisfy this condition. That is the importance. Okay, so n is equals to 6 is the least natural number which satisfy this condition. Okay, so this question was very important, and we have discussed this question. I have explained this question thrice. Hope you have understand this question. Okay, we are moving forward. Okay, the next question, which is this. Okay, the next question is this. Okay, if the sum of the series, okay, summation n is equals to 0 to infinity Rn. Okay, for mod r less than u, I have told that this is the modified version of telling summation in infinity, although you again get the identification that it goes to infinity, the sum of infinite terms in GP. Okay, is s. Okay, they are telling that it is s. Then find the sum of the series summation n is equals to 0 to infinity, again n is equals to 0 to infinity r power 2n. Okay, now let's analyze this one. Okay, it is nothing but r power 0 is what, 1 plus r power 1, r power 2, r power 3 until what, infinity. Okay, and it is equal to what, s. Okay, now if I want to find the sum of this, what I can do, 1 minus r, this is this sum. Okay, now let me take it as a. Okay, now let's analyze this. What we want to find, let me take it as some t. Okay, it is some t. Okay, so what we have at 0 it is 1, and at 2 it is r square, and at 1 it is r square, and at 2 it is 4, and so on. Okay, now it will be what, 1 upon 1 minus r square. Don't you agree? Then after this okay, and we want to find this thing. Okay, this thing. Now what we can do, okay, what we can do, okay, here there is r and I can get r from here. So what I should do, I should bring 1 minus r upon 1 by s, and 1 minus 1 by s should be equal to my r, which is nothing but s minus 1 upon s is equal to my r. Okay, now let's substitute this here, which gives me nothing but 1 upon 1 minus s minus 1 upon s. Okay, the whole square, the whole square. Okay, further on what we are getting, this will be s square upon s square minus s square minus 2s plus 1. Okay, this is s square, which gives me s square upon, this will cancel out, which will become 2s, this will become minus 1. Okay, so we got our summation, which was t. Okay, this is nothing but s square. Okay, s square. Okay, s square, not 2s. Okay, s square into 2s minus 1. Okay, so this was, it was very easy question, nothing great. You want to find the sum of first, you got a hint that it is infinity sum series. Okay, then you did the sum, you got idea that here r should be substituted, where we should get r from the 1a. So we got our r from there and substituted it and got our answer. Okay, so let's move on to the next question. This question is question number 9. Okay, this question number 9, the question number 9 says prove that 6 power 1 by 2 into 6 power 1 by 4 into 6 power 1 by 8 till infinity is equals to 6. Okay, is equals to 6. Okay, now this question is very, means not that much great. Okay, in power, okay, constant same number multiplied, and power is power are different, then we can simply add the power, 1 by 2, 1 by 4, 1 by 8, like that. Okay, till what, now one more thing, if it is going to infinity, then the power will also go to infinity. Okay, please don't make a confusion in that. Okay, please, you should know that if the product of terms, okay, having some random power goes to infinity, then the when the power is added, it also goes to infinity. Okay, student have some phobia that it goes to n, 1 by n, 1 by 2n. Okay, sorry, if it is, they have given you that it goes to infinity, then it also goes to infinity. Okay, please don't do these mistakes, okay, in question, because these questions are very easy. If you do mistake, you are losing the marks which was just means which was in your hand, which was for everyone. Okay, you are losing that marks. And for hard question, if you do that, you get advantage over other students. Okay, now 6 power, this is okay, what is ratio is, okay, r is less than 1. Okay, you can understand this. So let's understand the sum separately, 1 by 2, 1 by 4 till 1 by 8, and still so on till infinity. And the first term is 1 by 2, 1 minus 1 by 2. Okay, this is nothing but 2 by 2 into 1. Okay, 1, we are getting 1, so it is nothing but 6 power 1, which is nothing but 6. So hence we have proved this question. Okay, it was nothing, just you know to know that if the multiplication goes to infinity, then the product at the power, okay, the number which are variable in the power which is variable, it also goes to infinity. Okay, we did that sum, it is a GP, we analyzed that, and we, after solving it, we got a 6 power 1, which is nothing but 6. Okay, now let's move on to the next question. Okay, the next question is this question. Okay, this is the next question, which is question number 10. Okay, which is find the sum of n terms of the series. Okay, we want to find the sum of n terms of the series. How we can do it? Okay, the more important, this question is quite different from what. Okay, so let's analyze this. if you have remember, there was one question which was 1 plus 1 by 2 plus 2 square, okay, and in the next 1 plus 2 plus 2 plus 2 cube. The difference in this question appear is 1 plus 1 plus 1 by 2 plus 1 by 2 square, okay, 1 plus 2 square. This term repeats, and then there is what two more terms addition, okay. So here using the TN technique fails, okay. That why we are not going to do it by TN technique, okay. Means we are going to find the TN, analyze, and then put T1 T2 T3, okay. Then check whether it gets simplified into some GP or not, and then separately solving them, okay, into different GPs, okay, or different series, okay. That was our main thing which we are doing in the previous question, okay. Although it looks similar to, but it is 1 by 2, and here two terms are being added in the preceding term, okay, in the next term, okay, sorry, in the next term, in 1 by 1 by 2 plus 2 square, and the next term 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 by 4, until so on. Okay, now let's find the sum of each term, whether we can get the means some similarity in the n terms or not. If we getting some n term similarity, then we will understand the question. So let's do this question, okay. So here in the previous question, what we used to do, that there were two means a, it was like 2 2 2, and there was one more term. So we used to analyze the TN term and then get a general TN term, and then identify whether we can break it into some small TNs, okay. But here it fails because two terms are being added in the back. So let's analyze the sum of each, so S1 S2 S3, and then try to figure out whether we can find the S of n terms or not, okay. Okay guys, now let's begin with the first one, okay. It is 1, okay. Now this one, it has a1, okay, and n is 3. So 1 into 1 minus 1 by 2, okay, by 3 upon 1 minus 1 by 2, right. Similarly in this 1 into 1 minus 1 by 2, okay, how many terms? 5 by 1 minus 1 by 2, okay. Now what we are getting, and so on. So here 1 plus, this will become 2 into 1 minus 1 by 2 the whole cube, plus 2 into 1 minus 1 by 2 power 5, and so on. So here you can see it is 2 into 1 minus 1 by 2 the power 3, 2 into 1 minus 1 by 2 power 5, until so on. Next will be what? Next we can analyze that it will be 1 minus 1 by 2 power 7, and so on, okay. So I can add. So if I multiply multiply it by n by 2, which is outside, what I get, 2 minus this will become 1 by 1, 2 will cancel out, which will give me 2, plus 2 minus 1 by 2 power 4, plus 2 minus 1 by 2 power 6, and till so on, okay. And here is my first term 1, okay. Now these are total n terms, okay. N terms, they have told it as n terms. Further on here, if I bring all the 2's, 2 plus 2 plus 2 plus 2 plus 2, and till how many terms? Here one term is missing, okay. Rest all are what? N minus 1 terms. So the last term will be n minus 1, okay. If I bring minus of this, 1 minus 4, 1 minus 2, 1 by 1 minus 2 power 6, 1 by 2 power 4, then what I will have inside? 1 by 2 power 2, 1 by 2 power 2 4, 1 by 2 power 6, and so on till n minus 1 terms. Here also, because one term is here, so it would have been n, but since 1 is not included, so it will be n minus 1, okay. So 1 plus, if I add them, I will get 2 into n minus, I will take 2 common, then how many terms are n minus 1? So 2 into n minus 1, okay. That's how it came. Further on here, my first term is 1 by 4, you can easily see it, and my common ratio is 1 by 4 also, 1 minus 1 by 4 by n minus 1, right, upon 1 minus 1 by 4, okay. So this is my sum, okay. Further on, 1 plus 2n minus 2, okay, minus this minus is still here, okay. This is what? 1 by 4, this 4 will cancel out, okay. And what we can get from here is we are getting 3, okay. This will be 1 minus 1 by 4 power n minus 1 upon 3, 4 will cancel out, okay, which gives me finally what? which gives me finally 2n minus 1 minus, okay, this will be minus. So what we have, okay, here it is 2n, okay, 2n minus 1, and here we have finally what we have, okay, here we have 1 by 3 minus what, 1 by 2 power 2n minus 2, right, 1 by 2n minus 2 power 2. Okay, so what we can do now, okay, what we can do, what we can do okay, let's do one thing. 2n minus 1 is here, okay, so it is minus, so it will be minus 1 by 3, okay, and this will be plus 1 by 2 power 2n. This 2n minus 2n can be written as 4, okay, okay, let me take the next page. Okay, this is minus 2n, so it can be written as in the denominator 2 power 2, which is nothing but 4. So in the next step, what I can write, 2 by n minus 1 minus 1 by 3, okay, plus what, 4 by 2 power 2n, okay, and this will give me what, 2n minus 3 minus 4 by 3 plus 4 by 2 power 2n. Okay, if I take 4, here is 3 also, here it is 3, okay, I think I didn't put it, here it is 3, okay, 3, okay, multiplication 3, okay. So if I take 4 by 3 minus 4 by 3 common, what I have finally, minus 4 by 3, if I take common, what I have finally, I have 1 minus 1 by 2 power 2n, okay, here. Okay, so this is our answer. The main thing is that here, since you cannot analyze the Tn term, so we are analyzing the sum. Okay, by analyzing the sum we are getting T1 T2 T3. Here by analyzing the sum we are getting T1 T2 T3. Okay, and here n minus 1 term also plays a crucial role. If you forget to identify n minus 1 term, then your everything will go into waste. Okay, all the things. Okay, so the important things are being understanding what should be the process of these type of question. Okay, and since we are done with this question, let's move on to the next question. The calculation is tough, I know, but you need to understand this. Okay, okay, so let's move on to the next question. I took one extra page. Okay, so let's move on to the next question. The next question is as follow. This is the next question, which says if the sum of the first two terms of an infinite GP is 5 and every term is 3 times the sum of all the terms that follow it, and then find the series. Okay, this question is similar to one question which we have done, which used similar language. Okay, I told you you should understand the language of the chapter. Okay, so if you have understand that question, then you will understand this question. Okay, so what is telling first of, so let me take a GP AR. Basically we take GP like that only, AR cube and till so on. First two terms means A plus AR is nothing but, okay, sum of first two terms of an infinite, and it is going to infinity, okay, is equals to 5. Okay, we got this thing. Now they are telling the sum of first term, any term, is 3 times the next term, AR square, okay, AR cube, and so on till infinity. Okay, why it goes to infinity I have discussed in earlier videos also. If it is going to, it will go infinity only. Okay, one term is, it doesn't make any change. Okay, so let's find the sum of this AR upon what, 1 minus R. Here it is A will cancel out 1. Although I can do that with it AR, okay, second term with third term, but taking first term will make our calculation easy. That's why we are taking first term. Okay, you can do the second term, doesn't matter, you will get the same answer only. So we are getting 1 by okay, 1 is equals to 4R. We are getting R is equals to 1 by 4. It should, we should, if we were getting some 3-4 number, then our answer was definitely wrong, because R should be less than between 1 and minus 1. Okay, that is infinite GP condition, and yes, we are getting 1 by 4, which gives that, which tells that we are going in the right direction. Further on, now let's put here the value of R is equals to 1 by 4 and get our answer. So A plus A by 4 should be equals to 5, which gives me A is equals to this is 5A is equals to 16 for 20, so A is equals to 4. So we got A is equals to 4 and R is equals to 14. This is our answer. Okay, so let's move on to the next question. The next question is this question number 12. Okay, next question is question number 12, which tells if ai means first term belongs to R, I is equals to 1 comma 2 comma 3 till n, and all ai are distinct such that a1 a2 a3 till a, okay, are in first a, ap, gp, chp, or none of these. Okay, one extra thing is given, that is in this question they have given one extra thing after giving the option, which is I is equals to 1 to n minus 1 I ai square into x square plus 2 into summation I is equals to 1 to n minus 1 a1 into ai plus 1 into x plus summation I is equals to 2 to n ai square is less than equal to 0. Okay, now this question seems very difficult to analyze. Okay, if you, many children, when they will see this they will run away. Okay, leave this question. Okay, although this question is not that much what it shows itself. Okay, so what we should do, okay, can you see it is forming a quadratic ax square plus b 2bx, okay, a plus b the whole square, okay, a plus b, yes, a plus b the whole square, ax square plus 2ab plus bx square. Okay, so here if I take it as a x square, okay, sum a square, 2a, okay, a is there, into b, but here b is something else. Can we make it like this? Okay, let's understand. If the summation is like that, then we will get our answer. Okay, I is equals to 2 to n, okay, ai the whole square. Okay, what we are getting, a2, they start from a2, a3 square, a4 square, okay, like that till so on, a n power whole square. Okay, we are getting like this. Now can I write it like this, I is equals to 1 to n minus 1 a I plus 1 the whole square. Here if I put 1 I get 2 square again, here if I put 2 I get 3 square again, here if I put 4 I get here if I put 3 I get 4 square, like that, and still so on. What, and if I put n minus 1 plus 1 the whole square, I getting a n square. Okay, so all the things are same, so I can replace this by this. Okay, so what we are getting in the end, so we are getting summation I is equals to 1 to n minus 1 ai square into x square plus 2 into summation I is equals to 1 to n minus 1 into ai plus 1 into x. Okay, if you have analyzed that it is a quadrant, it is a plus b the whole square, then your job is done. Okay, I can write I is equals to 1 to n minus 1 into I plus 1 the whole square. If you have done this, your job is done. You can clearly see a square plus b plus 2ab plus b square. How? See, this summation will move out. I is equals to 1 to n minus 1, condition that this should be same in all. Okay, so it is moved out. So what I have, ax, okay, plus what, ai plus 1. Okay, so we are done with this, and it should be less than equal to 0. Okay, the whole square. Okay, so what we can do now, if I elaborate this, means open the summation using this, I is equals to n minus 1, I have a1x plus a2, okay, the whole square. Okay, what this is, plus similarly a2 x plus a3, okay, a3 the whole square. Okay, and till so on. Okay, should be less than equal to 0. Okay, now when sum of square of terms, okay, all, and here they are given that ai are distinct. Okay, distinct. Okay, distinct, or ar belongs to r. Okay, means they are real number. Okay, they belongs to r. Okay, so real numbers means if I tell x a square plus b square plus c square, okay, they should be less than equal to 0. Okay, they cannot be less than 0. The only situation arrives in a square plus b square plus c square should be equal to 0. Okay, let me take the next page. Okay, let me take the previous page only, which we are used. Okay, so let me use this page. Okay, so the only condition which is possible, that a square plus b square plus c square should be equal to 0. It cannot be less than 0. For that, a should be 0, b should be 0, and c should be 0 for this to happen. So here if you observe, okay, a1 x plus a2 should be equal to 0. What it gives, x is equals to minus a2 by a1. Similarly, if I do this with second term, minus a3 by a2 should be equal to 0.
with the third term, it gives me that minus a4 by a3 should be equal to 0, and all are equal to x, okay, some constant ratio. So we are getting an idea of that it is all equal to 1, that is minus a by 2 by a1 is equal to minus a3 by a2 is equal to minus a by 4. So what it gives us hint that it is a GP, it is a GP, it is a GP. Okay, so there was nothing, means you should have not got afraid of this and just analyze a plus b to ab plus b square. Okay, if you have analyzed that thing, your job would have been done and you have been getting the answer b as GP. Okay, many children get scared of this question. This question has nothing, you just need to analyze this. Okay, although if you have understood this starting part and you have did the manipulation of this, you would have got this answer. You should don't need to get scared of this submission. Just try to open the submission and analyze it. Okay, don't just run away by seeing the submission. Okay, now let's move on to the next question. Okay, hope you have understand this question. We opened this, we got the idea a square plus 2ab plus b square. We made it b square because it was ai plus 1, so indirectly I got a hint that I should make it like this. Then I analyzed it, it was yes equal to this, so we replaced this by this and we got a plus b, a square plus 2ab plus b square. Okay, so we analyze this and then we move the summation out. Remember that to do these things, the summation, all the summation n minus 1, all it should be equal, the starting and the final limit should be same. Okay, I is equals to 1 to n minus 1, all they have same. Okay, then I is equals to 1, n minus 1 took out, and then ai x plus a I plus 1, the whole square should be less than equal to 0. Then we opened it. Okay, it should be less than equal to 0. Further on we got an idea that it cannot be less than 0. A square plus b square can be equal to 0, so we made individually term 0, a1x plus a2, and they are being equal to some constant ratio, which gives us idea that it is a GP. Okay, so we are done with this problem and we are going to move on to the next problem, which is question number 13. Okay, which is question number 13. This is question number 13. Okay, it says, okay, it says if summation r is equals to 1 to infinity 1 upon 2 r minus 1 the whole square is equals to pi square by 8, then summation r is equals to 1 to infinity 1 by r square is equal to a pi square by 24, b pi square by 3, c pi square by 6, d pi square by 12. Okay, now let's open this thing. Okay, as I told, just analyze the summation. What it gives, 1 upon 2 r minus 1 the whole square. What it is, at r is equals to 1, it is nothing but okay, it is 1. At r is equals to 2 is what, 3 square. At r is equals to 3 is what, okay, at r is equals to 2 is 3 square, right? At r is equals to 1 it is 1, 3 square. Further on, at r is equals to 3 it is nothing but 5 square, and r is equals to, see, it is 7 square. So we got an idea that it will be like that. Okay, so till infinity. Okay, so it is sum of infinite. Okay, now they have given that it is equal to what, pi square by 8. Okay, 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square. Okay, till infinity it is equal to this. Okay, now if I analyze this one, okay, second one, r is equals to 1 to infinity 1 by r square. Okay, what it is, it is 1 plus 1 upon 2. If I place 4, 1 upon, okay, 2 it is 4, 3 is equal to 9, and 4 is equals to, 3 is equals to 4 is equals to 16, and 5 is equals to 25, and so on. Okay, so we are getting something like this. Okay, so what we can do, okay, what we can do, we have 1 by 1, 1 by 4. Okay, can you see that it is 5 square, it is 3 square. Okay, this okay, this is 4 square. Okay, this is 2 square. Okay, so we can arrange it, okay, till it is infinity. So can we arrange it like 1 plus 9, okay, which is nothing but 3 square, then 1 by 5 square plus 1 by 7 square, okay, until so on. Okay, these odd terms. Okay, and then separately we can separate 1 by 4, 1 by 2 square, 1 by 4 square, 1 by 6 square, 1 by 8 square, and so on. Okay, and so on. So what we are getting, that this is equals to pi square by 8. Okay, and let me call that it is equal to some x. Okay, its value is equal to some x. Okay, now what we have, if I analyze, I have 2 square plus 2 okay, 4 square, sorry, 4 square, and 1 by 6 square. Okay, 1 by 8 square. Okay, so what we can do, okay, what we can do here is okay, we can do one thing like this. Okay, if I take 1 upon 2 square common from all these, what we have, 1 plus 1 upon 2, this is what, 2 square into 2 square, okay, 4 into 4, then it will be 16, so it is nothing but 2 square, okay, 4 which is 2 square, okay, and here we are getting what, 3 square, and here we are getting what, 4 square, and here we are getting like 5 square, okay, until so on, if I take 1 upon 2 square common from all of them. Okay, so if you observe means if you observe this thing, then we call it as x. Okay, if you observe this thing, then your job is done. Okay, you got the answer. Okay, this is what, pi square by 8. Okay, and if you analyze that it is nothing but x only, then you got your answer, it is x by 4. Okay, so now what we want to do, if we move this x minus x by 4 here, it should be equal to pi square by 8. This multiplied by 4, this is 3x by 4, it should be equal to pi square by 8. 8 will cancel out, which will give me x is equals to nothing but pi square by 6. So what is C is our answer. So C is the answer. So C is the answer. Okay, C is the answer. Okay, so what was this question? This question was nothing but we analyzed the first, we analyzed the second. The trick part was taking 1 by 2 square common. How it comes, if you observe clearly, if you understand the question, okay, if you will slowly get understand with the series. Okay, you will get means you will get how to tackle. Okay, if you see variety of problems, okay, then only you will understand how to do. Okay, so this was it. So this is how we did, we analyzed it. Okay, 1 by 2 square you will come by experiencing doing different problems. Okay, then we got x pi square by 8 plus x by 4, and then we moved it that side, and then we came to know that pi x is nothing but pi square by 6. Okay, so C is the answer. Okay, now let's move on. Okay, let's move on. Okay, so if we move on, what this is the next question. Okay, this is the next question, which says 2 plus 4 minus 8 plus 16 plus 32 minus 64 plus 28 plus 256 minus 152 plus and so on till 90 terms. Okay, so what this question teaches us, okay, these questions are some unique type of grouping questions, okay, which you should be careful. Okay, like these questions when appear, if you analyze, if we take 2 common, okay, what I have, 1 plus 2 minus 4. Similarly, if I take these 3 terms, okay, and I take these 3 terms and these terms, okay, if I take 16 common from here, 1 plus 2 minus 4. Similarly, if I take 128 common, I have 1 plus 2 minus 4, okay, until so on. Okay, so this is what, 2 minus 1, this is what, 16 minus 1, and this is what, 128 minus 1. Okay, so if I take 3 terms, it will become 30 terms. Okay, and all have minus sign. Okay, so this is what grouping. Okay, if you identify the grouping question in groups, if they have some common, take common. Okay, and then make it simple. Okay, that is the motto of this question. Okay, I analyze the 3 terms. Okay, if I take 2 common, it will 1 plus 2 minus 4. Okay, it will be 16, 1 plus 2 minus 4. Okay, and 128, 1 plus 2 minus 4. Okay, and so on. Okay, so 2 into minus 1 plus 16 into minus 1 plus 128 into minus 1 until 30 terms. Okay, so what we have, 2 into minus 1. Okay, sorry, if I take minus 1 common, what I have, 2 plus 16 plus 128 and so on. Okay, till what, 30 terms. Okay, till what, 30 terms. Okay, now we want to find the sum of these things. Now I have ratio as what, my ratio means my first term is 2, so 2 into 8 power what, 30 minus 1 upon 8 minus 1. Okay, it gives me what, minus 1 into 2 into 8 power 30 minus 1 upon what, 7. Okay, so we got this thing, which is nothing but minus 1 into 2 into 8 power 30 minus 1 upon 7. Okay, so this is our answer. Okay, so we are done with this problem, and this is our answer. The main thing is to teach you how to do grouping. Okay, if you understand how we did in this question grouping, then you have done with this problem. Okay, and similar questions you can see, okay, you can just expect to see in different books. Okay, to that grouping questions, how we need to do and how we need to have our mindset. Okay, it can also be like the 3 terms give here and 2 terms like here, and you have to arrange them and then get a grouping. It can also be, such scenario can also be possible. Okay, so be ready. Okay, this question is just give you such critical situation be occurred, and they will just do a little variation in that. Okay, hope you will be able to analyze that. There is nothing that, but you should know this problem type. Okay, now let's move on to the next question. Okay, this is the last question of this session. Okay, the question is, if a comma b comma c are in GP and x comma y are the respectively the am between a comma b and b comma c, then prove that 1 upon x plus 1 upon y is equals to 2 by b and a by x plus c by y is equals to, so we have to prove two things. Okay, now they have telling a, b and c are in GP and between them x, okay, and between them y are in AM. Okay, so one thing is very simple, 2x is equals to a plus b. How I can got when terms are in AP? Okay, and the second is 2y is nothing but b plus c. Okay, this is the second equation which you can get 1 and 2, second equation and first equation. Okay, further on, what thing which you can get extra. Okay, now let's put the values and see what we can get. If I put the value, what I have, a plus b by 2 x value, and here if I put the value, I have b plus c by 2 is further on. Okay, what it will become, 2 plus a plus b plus 2 upon b plus c. Okay, now the trick part is that a, b, c are in GP, so I can write it as a, I can write it as ar, I can write it as ar square. Okay, so if I substitute that 2 into a plus ar plus 2 upon a plus ar into ar square. Okay, then what we have here, if I take 2 into a, okay, 2 into a common, 1 I have 1 plus r. Similarly, if here I take 2 here ar common, then I have 1 plus r. Okay, now if I take from both 2 upon 1 plus r common, okay, then what we have, 1 upon, okay, a also common, then what I have, 1 plus 1 upon r as my left term, which is nothing but 2 into a into 1 plus r, which gives me 1 plus r upon r. Okay, so 1 plus r will cancel out, and which gives me 2 upon ar. And if you remember, what is 2 upon ar, it is nothing but 2 upon b. So this is how we will do the problem. Okay, there was nothing great, just using the GP of concept of a, ar and ar square terms. Okay, so we have proved the first thing. Okay, called me it first and it means called it second. Okay, now let's substitute the value in the second. A upon x is what, a plus b into 2, and 2 into c upon what, b plus c. Okay, b plus c by 2. Okay, right, now we want to prove it that it is equal to t. Okay, so what we can do, it is a plus ar, right, and this is 2 into c, this is nothing but a r plus ar square, right. Okay, so what we can do, okay, c I can write it as ar square. Okay, then a will cancel out, which give me 1 plus r. Okay, similarly here a r will cancel out, which give me 2 up by r. Okay, which give me 2 by, here 1 plus r will be left. Okay, so finally what we have, 2 into 1 plus r, if the denominator is same, so what it left with, 2. So this is our answer. Okay, so the second was more easy than first was little more manipulative than the second. Okay, there was nothing great, just using the am concept, the gm term concept, and then substituting and getting the answer. Compared to the previous question which we have, this is nothing. Okay, so we are done with the question which we wanted to do in this session. Okay, we will see you in the next lecture. Okay, and we will do some more cover problems on GP and then wind up the GP and move on to HP. Thank you.